Okay, having said that, I was reviewing our class yesterday and I noticed I committed some blunders, so apologies for that. So I thought we begin with that today. So I've taken notes, two things. Uh, I hope, maybe not. The idea of y is equal to x squared. I tried to draw a function yesterday and I said it's not a function, or maybe that's not what I said, but if that was what I said, then that was wrong. I meant y squared equals x is not a function, not y equals x squared. So I wanted to correct that. I'll write it on the board. The other thing is well-defined function. I wrote something wrong in the definition of well-defined function. Let me try to find the Zoom folder from yesterday. Yesterday was 24th. Okay. Aha, all right. So I'm going to show you my desktop. Can you guys see this? Okay. All right. So the error is this was interchanged. Okay. So it's not this implies this. It is the other way around. I meant the converse. I will write it properly. So it should have been f is well defined. If whenever you pick two elements in the domain and the two elements are the same, the images must also be the same. That is, you can't have two different images. So it's not supposed to be x1, y. It's supposed to be x, y1, x, y2, such that y1 equals y2. All right. So those are the two things that was said in error. The other one was okay, maybe I erased that from the board. Okay, the other one is not here. Okay, I think I erased that from the board, so don't worry about that. Let's go to the board now. Okay, so let's write today's date. I believe nothing is obstructing the board today. I try to minimize the chat, so please, as much as possible, talk to the mic. So, because the moment if you answer my question by typing, I have to go find the chat that I've minimized to be able to see your response. So, if I need to enjoy the full screen, I need to actually minimize the chat. Okay, so as much as possible, please try to use your mic to respond. Unless in cases where your mic isn't working, then I understand that perfectly. So the first thing again is the correction from yesterday. So let's take note of, so let's write the date first. Today is 25th. And for this time, we say goodbye to February. Fortunately, I don't get to see you guys in February. Too bad. Anyways, Tuesday. There's some corrections, okay? So the first thing I would like to correct is this definition of well-defined function. So let's put it this way. So let's A, B be non-empty sets. Okay, let A and B be an empty set such that f is a function that maps elements from A to B. Okay, f is a function that maps elements from A to B. That's the meaning of what I've written. That is, f takes elements from A and the result is always in B. Does that make sense, everyone? I have the chat box here, so please just type in yes. If I'm writing the full board, I will have minimized the chat, then please feel free to. So the function f is well defined if for xy, for any xy, for any two arguments, all right? The argument is from the domain, okay? For any two arguments that you have, such that they are equal, okay, we must have f of x equal to f of y, not the other way around, okay? Yesterday I mentioned if we have f of x equals f of y, then x must be equal to y. No, I should have put it the other way, okay? So what does this say? It means if, for example, you can pick values from the domain, whenever you pick values from, and those values are the same. So if those values are the same, it means I have A and I have A, okay? If these two are the same, the only possibility is for these two to also be the same. So whenever this is B and this is B prime, then this is only possible if B and B prime are also the same. Am I making sense, guys? Not the other way around. Okay, so what are we talking about here? I can put it this way and say that is if A, B prime and AB, sorry, AB and AB prime belongs to F. What this means is that this point, okay, is in this relation. Remember, a function is a relation, okay? So this is and the relation is a set of points, okay? A set of ordered pair like that, okay? So if whenever this relation, these two ordered pair belongs to F, you can see that the A's are the same, the arguments are the same. These are the elements from the domain. If these two belongs to F, F can only be a function if these are exactly the same, which means the points are not different. So there is no way you can have 3 and 4 and also have 3 and x where x is not the same as 4. It's not possible. Okay, so if this happens, then B and B prime must be the same. Your B and B prime, remember, if this happens, then B and B prime must be the same. Okay, I put a note here. Your B is actually F of A. Okay, that's the notation we are using. That's the meaning of this. So if I write xy belongs to f, it simply means f of x is equal to y. Does that make sense? It means f acts on x to produce y. Questions? Questions? All right, so please take note of that, and sorry about the mix-up yesterday. Another thing I wish to correct, hopefully that's not what I said, but something tells me that was what I said. Y equals x squared is a function. What I meant to say, what I thought I was talking about is y squared equals x. That is not a function. Okay, this is a function. This is not a function. And we will see now. Y equals x squared is a function. Let's see. If my domain is set of R, is there any R? Any R, okay? Is there any element in R that cannot take, that X cannot take as value? Any value in any real number that X can't take as value in this function? Is there any? Can I get a response, please? My point is, or in the layman's term, is there any number you cannot substitute as X in this function? Come on, guys, can we respond in seconds so that we can be faster? So, Krista, are you saying imaginary numbers cannot be substituted? If X take an imaginary number, X is equal to maybe A plus IB, are you saying you cannot substitute to get equivalent Y here? You cannot? You can, exactly. Yes, you can. So there is no number, R or C. Besides, I was talking about real numbers. We are not discussing complex number. And complex, even complex can be substituted. So it means this meets the, satisfy the first condition. Remember the two conditions that we wrote yesterday, if I may quickly write that. The first condition is that F acts, okay, F maps, if I may use that word, F maps every element in the domain, okay? F must be able to map every element in the domain to some elements in the range. It means no element is left out. So if I have three elements here, I will talk about this later. It's called arrow diagram. If I have four elements here, every element here can go there. Okay, no element will be left out. So for example, if I have this, so I cannot call this a function because this guy is left out. Understood, everyone? That's the first condition. The second condition is that F must be well defined. So these are the two criteria. So the first one is satisfied because if you take R as the domain now, every member of R can be substituted. Okay? Every member of R can be substituted. When I say map, if I have here 1 and I have here 2 and I have here -1, okay? And this is my F, which is x squared, all right? This will be 1, this is 4, let's say 9. You can see 1 is mapped to this, 2 is mapped to that, minus 1 is mapped to that. Everything here is mapped to something here. We are not saying that everything here must have something here, all right? Everything here must have an image. Every member here must have an image. That's the first condition. So basically, f of 1 is equal to 1. F of 2 is equal to 4. F of negative 1 is equal to 1. So it means that f maps 1 to 1, f maps 2 to 4, f maps minus 1 to 1. Does it make sense, please? Please respond so I proceed. So the mapping is saying it can connect, basically, all right? It can connect it. Okay, so that's the first one. The second is f is well defined, okay? F is well defined simply means if I pick two elements here and they are the same elements, okay, then they must have the same image on the other side. So, of course, it means that no two images here can be linked to this part. Can you see? So look at 1 and 4, 1 and 9, 4 and 9. No two that I pick here can be linked to the same X in this part. That is the well-defined. So if I pick any two and those two are discovered to be the same, if those two gives different images, then those images are not different. Okay, so that is the definition of well-defined. So and you can see that this meets up with that. So this is definitely a function. Okay, this is definitely a function. What's going on? All right, so this is definitely a function. Is that understood? And you can see that actually from the diagram. If you draw the graph of this, y equals x squared, you get a parabola, okay? And it's going to touch at 0. Pick any x, it doesn't link to more than one y. Okay, pick another x, it links to only one y. Pick another x, it links to only one y. So you don't have a situation whereby if you pick an x, or you get a y here, and maybe the same x gives another y here. It's not possible. Does that make sense? Let's talk to me, guys. Does that make sense? Hello. All right. So the one, can I explain again? Okay, the diagram one, Nakita. Is okay? Okay, maybe when I write this, you can see. If on the other hand, I have y squared equals x, this is not a function. This is not a function. And the reason is simple. If I try to use algebraic approach, y equals the square root of x. Okay? Is the first condition satisfied if I use r? Come on, don't be silent. I'm talking to you guys. I don't want to have to say respond before somebody says something. A lot of people are just laid back, waiting for maybe one or two people to talk. Is the first condition satisfied? Can my f, if this is f, so basically f of x equals square root of x. If I define this from r to maybe r, can the first condition be satisfied? Are you sure? You're not looking at it closely. And please use the mic. Except your apartment is so noisy. If it is not so noisy, please, I need to hear you. Use the mic. Is the first condition satisfied? I don't think so. I don't know if you're seeing.
You can get decimal, right?
What?
You can get decimal.
Is the decimal number in R?
No. Wait. Yeah.
Is it in R or not?
Wait, no, yeah, there are. Never mind.
Never mind what? Like we could get decimal or what?
Yeah, you can.
Yeah. Okay.
I mean, unless x is -1, then you get imaginary.
So does that mean it satisfies the first condition?
No.
No. So even for failing to meet up with the first condition under R, then there's a problem, right? And you have to satisfy these two conditions to be considered, to be considered a function. Is that understood, everyone? So even considering the first condition, it fails. Now, even if you allow, if we exchange this to C, does it satisfy the first condition? Do I need to call names before I get replies from people? Does it satisfy the first condition if I change that to domain is R and the range is C? Yes, I got a yes from Vena. Is your mic broken, miss? Can you explain? Construction is loud today. Okay, all right. Can somebody explain? She said yes. Mr. Cheng? Not you again, not you again. What happens? Where is Krista? Krista. Where is Leo? Where is Brandy? Where is Karen? Where is Calista? Who am I missing? This is my class attendance. This is not everybody. Clarissa. I'm waiting for the names that I called. You have not said anything. If you are not on, I don't really know. I'm not sure. Do you understand the meaning of the first condition? And I need you to talk to your mic and stop typing if construction is not going on behind you or where you are. And please, fast. Do you understand the first condition? Clarissa said yes. Okay. I'm waiting for the others.
Can you explain it again?
Okay. You mean the first condition of what?
Yeah, the first condition.
Okay. So the first condition says F maps every element in its domain to some elements in the range. It means F can take any value here. It means you can substitute any real number and it is possible to get an answer. That's what it means. So if I say, if F is defined from A to B, it means under this function, every element in A can be substituted. So F of something equals an answer, right? It means everything in A can actually be substituted here. So in the first situation, we checked, can every real number be substituted here? So Karen, can you answer that question? Can you substitute every real number, every possible real number here, and you won't run into trouble? Yes or no, please?
Yes.
You sure?
I don't know.
Okay, can you substitute every real number? So if you pick any, is there any real number you cannot substitute here? That's the point. Is there any? If the answer is no, then it means the first condition is satisfied. Under this arrangement, the domain is R, the range is R. It means when you substitute real number, your answer must be a real number. So the question is it possible to substitute every real number? Or are there real numbers you cannot substitute under this arrangement? Anyone? Karen, Clarissa, Callista, Krista, Brandy, and Lil.
-1.
You cannot substitute negative numbers. Because if you put negative number here, you're going to end up getting f of -1 is square root of -1, which is equal to I. And this says your answer must be in R. But this is not in R. Does this make sense? So it means
Yes.
arrangement, this function fails. So if this is my domain and this is my range, it means it fails the first condition, which means this is not well defined. Which means this is not a function. Does it make sense? Now, I've changed the domain. I'm still talking to the same set of people whose name I called. I changed the domain to this. Can the first condition be satisfied with this definition if I change the domain and range to this? I'm talking to the same set of people, please. Leo said yes. Okay, yes. Because now you don't have to be afraid to put a negative number. If you put a negative number, worst case scenario, you get a complex number. But look at it. If I put in maybe a positive number, like 9, I get square root of 9, which is 3. Is 3 a complex number? I'm talking to those people alone. Is 3 a complex number? I'm waiting for replies. Clarissa said no. I'm waiting for others. No. No. Ethan, what do you think? Lillian says yes. Ethan says yes. Exactly. 3 plus 0i. So 3 is a complex number. Every real number is a complex number, but not every complex number is a real number. So it means the first condition is satisfied. But is F well defined? Then that's, so it means under this condition, under the first condition, the first one fails, so we don't have to check the second one. But under the second condition, the first one works, but the second one, let's check. The second condition says, F is well defined. It means for one X, can you get 2 different Ys? That's a summary. F is well defined. So condition 2, for one X, X value, can we get 2 different Y values? Krista says yes. Can you explain with your mic, please?
Because if X is 9, then Y can be -3 and 3.
Perfect. Which is against this rule. That is, if you have the same X and you have 2 different Y, those 2 must be the same so that this is not different. But in this case, under this 9, 3, and 9, -3 actually belongs to F. And we know that even though 9 and 9 are the same, 3 and negative 3 are not the same. So F is not well defined. Any questions? Questions? No? So it means if you draw a picture, the arrow diagram, this is what you get. 9 will be mapped to 2 elements, which is wrong. And if you draw the graph of this function, you should have something like this, if I'm not mistaken. So for a single x, how many y values can you see? Two. So for a single x, you see, this is one y value, this is another y value. So this is wrong. So Nakita, I believe that explains this because you can only see what I'm trying to say if you see the opposite. I believe that explains the first one clearly because you asked me the other time. Get it now? Yeah, I knew this would make it easier. Okay, everyone? So there are 3 different ways I'm visualizing this. I'm using the arrow diagram, which I'll introduce to you soon. I'm using the algebraic approach by checking the first 2 conditions, and I'm using the graph. These are the 3 ways you can visualize this to see if it is a function or not. Most of the time, all you have to check is the well-defined, most of the time. Okay, so if I ask you, is this a function? Just go to condition 2, check if it is well-defined. That's enough. Okay, just because for the first one, you can always manipulate your domain to make it satisfy. Okay, but you cannot manipulate the well-defined condition. So you go straight to your well-defined condition. Does everybody get that? Okay, so we have geometric way to see, we have the algebraic way to see it. All right, okay, so that makes sense now. Now, let me show you some from the textbook. Okay, so this is about the correction from yesterday. Did we all get that? So again, well-defined is this, not the other way. Then this is a function. This is what is not a function. This is what I intend to discuss yesterday that is not a function. All right. So I intend to just do a recording on that separately. Then I will start the class properly now. Any questions before I stop this one? No? All right. Thank you. I'm sorry for the mix-up.